All right, let's talk about how to completely transform the way you handle data in Python. If you're diving into data analysis or data science, there is one library you absolutely positively have to know, and that is pandas. So let's get right into it and see why it's such a massive game changer. You know that feeling, right? You've got this huge data set, maybe it's a messy list of lists or some super complicated dictionary, and you just feel stuck. You know there's valuable stuff in there, but trying to pull it out feels like searching for a needle in a haystack. Well, this is where Pandas swoops in to save the day. And look, it's not just another tool, it's a whole new way of thinking. Pandas gives you these incredibly powerful but easy to use data structures that just bring order to all that chaos. It makes playing with your data not just possible, but actually intuitive and, dare I say, fun. So, what's the big deal? Why is everyone using it? Well, for starters, it handles annoying things like missing data with no problem. It gives you a super efficient way to slice and dice your data however you want, and it's got all these flexible tools for merging and reshaping it. But the real heart of Pandas are its two main data structures, the series and the data frame. And those are the stars of our show today. So here's our game plan. We've kind of touched on the why. Next, we're going to break down those two core components, the series and then the data frame. After that, we'll get into the super important skill of how to select the exact data you want. And finally, we'll look at the first few steps you should always take with any new data set. Okay, let's start at the beginning with the fundamental building block of everything in Pandas, the series. If you can get your head around this, everything else will just click into place. So what is a series? Well, the easiest way to think about it is as a single column of data. It's kind of like a Python list, but on steroids. And what makes it so special is that it has two parts. You've got the data itself, and then you have an associated index. That index acts like a label for every single data point, and it's what gives us all this incredible power and flexibility. Now check this out. Here's a pretty cool trick. You can actually create a series from just a single number, like the number 50 here. But there's one catch. You have to give it an index. And when you do, as you can see, Pandas is smart enough to just repeat that single value for every label in the index you provided. It's a super fast way to make a series where everything is the same. Now, a much more common way to do this is with a Python dictionary, and this is where that index really starts to shine. Pandas automatically grabs the keys from your dictionary, in this case, name, IPL team, and runs, and turns them into the index labels for their values. It's just so clean and makes a ton of sense. And this is where the real magic happens. Unlike a normal Python list where you'd have to write a loop, with a series you can perform math on the whole thing all at once. You can see here we're multiplying every value by 2, squaring every value, and even filtering to find values greater than 2, all with these simple one-line commands. It's so powerful. Okay, you ready to level up? If a series is like a single column, then the data frame is the whole spreadsheet. This is the absolute workhorse of Pandas. Seriously, you'll be using this like 95% of the time. At its core, a data frame is just a two-dimensional table, just like you've seen in Excel or Google Sheets. It's got labels for both the rows and the columns. You can change its size, and the columns can hold all sorts of different data types, numbers, text, whatever you need. A really great way to conceptualize it is to think of a data frame as just a bunch of series all glued together sharing the same index. So let's quickly peek under the hood. A data frame has three main parts. You have the index, which are the labels for the rows. That's called axis 0. You have the columns, which are the labels across the top. That's axis 1. And of course, you have the actual data inside. Now, you'll want to burn this into your brain. Axis 0 is rows. Axis 1 is columns. You're going to see that pop up all over the place in Pandas. So how do we actually make one of these? Well, one really cool way is to combine the series we just learned about. In this example, we have a dictionary where the keys become our column names, name and team, and the values are the series that fill up those columns. It's literally like stacking columns right next to each other. Here's another super common way, using a list of dictionaries. This time, each dictionary in the list represents a single row of data. And again, Pandas is smart. It looks at the keys inside those dictionaries and automatically creates the column headers for you. This feels really natural when your data is organized row by row. Now, data frames aren't set in stone. You can change them after you create them, which is a property we call being mutable. A really common task is getting rid of a column you don't need. And you've got a few ways to do it. You can use the simple del keyword. You can use pop function, which is cool because it removes the column but also gives it back to you in case you want to use it for something else. But the most powerful way is the drop method. Just remember, with drop, you have to tell it axis equals 1 to make it clear you're dropping a column, not a row.
All right, so we've got our data loaded into these awesome structures. But now, how do we pull specific pieces of information out? This right here is probably one of the most important skills you'll learn in pandas. Okay, for selection, we have two main tools, .lock and .ilock. Here's the difference. .lock is for selecting by the label, think L for label. ilock is for selecting by the integer position, think I for integer. But here is the most critical difference, the one that trips everyone up at first. With .lock, the stop label is included in the slice. With ilock, it's excluded, just like you're used to in regular Python. And this picture shows it perfectly. Look at the left. When we say s.lock, square brackets 0 through 2, we get the rows with labels 0, 1, and 2. The final label is included. Now look at the right. When we say s.ilock, square brackets 0 through 2, we get the rows at positions 0 and 1, and it stops before it gets to position 2. Getting this difference down is going to save you so many headaches later, trust me. And this whole idea works exactly the same for data frames. Here, we're using .lock to select rows by their actual labels, from quarter 1 all the way through quarter 3. See how we're using the names? This makes your code so much easier to read, especially when you have meaningful row labels. And here's the other side of the coin, using ilock. With this, we're grabbing the first two rows, so positions 0 and 1, and the second column, which is at position 1. It works just like slicing a list in Python, using plain old numbers for both the rows and the columns. So whenever you load up a brand new dataset, and it might have thousands or even millions of rows, the very first thing you need to do is just get a quick feel for it. You definitely don't want to try and print the whole thing out. And for that, you have two best friends, .head and .tail. Head will show you the first 5 rows of your data by default, and tail, you guessed it, shows you the last 5. As you can see, you can also give it a number, like .head3, if you want to see a specific number of rows. It is the absolute perfect way to quickly check out your data structure and make sure everything loaded in correctly. So to wrap it all up, Pandas is really your command center for wrangling data. It's designed to take that messy, raw data and turn it into something clean and structured, like a series or a data frame. It transforms that chaos into clarity, and that's what gives you the real power to analyze and understand what your data is trying to tell you. We've really just scratched the surface here, but you now have the most essential tools to get started. You can load data, you can inspect it, and you can select the bits you need. So the only real question left is, what awesome data set are you going to explore first? Get out there and have some fun with it.